Hello students, I welcome all of you to this very beautiful session of Infinity Learn by Sri Chaitanya. So students, what we are going to start now is the discussion of 31st January Shift 1 examination, and let's bring in the first question which is in front of us. This question over here was asked from ray optics, that too of prism. So a refractive index of a prism with apex angle, that is known as the angle of prism, is cot A by 2. The angle of minimum deviation is. So it's a very simple problem, and I would like to add on also over here. This was a repeated question which was asked in one of the shifts as well. Probably on 27th of January, this question came for the first time and it got repeated as well. So this was the first question which got repeated. Now the apex angle is given as cot A by 2. Right, sorry, the refractive index is given as cot A by 2, and we need to find out the minimum angle of deviation. So del minimum is simply equal to I plus E minus A. Okay, and in terms of minimum deviation also, del minimum A plus del minimum by 2 upon sine of A by 2 is equal to nu over here, right? So you needed to use this relation over here, and based on that, the correct answer over here was turning out to be option number C. Okay, so the relation was nu equals to sine of A plus del m by 2. Now many students whom I've interacted, they went on using del m is equal to mu minus 1 into A. That is the relation which is used for smaller values of A, that is the apex angle. But unless and until it is specifically mentioned, you need to use the exact formula which is over here. Now, a coin is placed on a disc. The coefficient of friction between the coin and the disc is nu. If the distance of the coin from the center of the disc is r, the maximum angular velocity which can be given to the disc so that the coin does not slip away. Very standard problem of centrifugal force. So basically on a disc which is in rotation about an angular velocity omega, and that we need to find out. There is a coin, so the force which will act on it is going to be m omega square r, and that should eventually be balanced by the friction force. That is the case, and this F should be lesser than equal to Fk. That means m omega square r should be less than equal to Fk, and based on that you will very easily get the answer, that is option number A over here. A very simple statement over here. Now moving ahead for the next one, the relation between time and x is t is equal to ax square alpha x square plus bx. The relation between acceleration and velocity. So this is also a very standard problem. First you need to differentiate, then you need to capture the value of velocity, then again you need to differentiate and get the value of acceleration, and once you have got the value of acceleration, whatever v you got in terms of x, there you need to replace it over there, and finally based on the calculations you will get a result that is equal to option number A. Simple problem, it's purely based on calculus only, and just differentiate it, you will get the value answer over here. Moving ahead for the next one, the parameter that remains same for molecules of all gases at a given temperature. So at a given temperature, the temperature is constant. What is the parameter that remains same for all of them? Is it mass, speed, momentum? The correct answer over here is kinetic energy. Kinetic energy is a concept which remains same for all of them. Kinetic energy is independent of the mass of the molecules because it is dependent upon the molecular mass. So based on the quantity of the molecules, it is independent. Now talking about the second one, that is when a metal surface is illuminated by a light of wavelength lambda, the stopping potential is 8 volt. When the same surface is illuminated by light of wavelength 3 lambda, the stopping potential is 2 volt. Then threshold wavelength for this surface is. What is going to be the threshold wavelength for this surface? So it's a simple problem based on two equations. One equation over here is going to be this one, hc upon lambda minus phi naught equals to 8, and the next one will be when the wavelength has been increased to 3 lambda, now the stopping potential is 2 electron volt, and based on that you can very easily find out the value of lambda naught, that is the threshold wavelength. You need to find out the value of phi, and based on that you can very easily find out that lambda naught is equal to 9 lambda, so the correct answer here is option number A. Okay, moving ahead for the next one. A coil is placed perpendicular to a magnetic field of 5000 turn Tesla. When the field is changed to 3000 Tesla in 2 seconds, an induced EMF of 22 volt is produced in the coil. If the diameter of the coil is 0.02 meter, then the number of turns in the coil is. Simple problem based on EMF, that is EMI. EMF generation will be minus of n d phi upon dt, where the magnetic field line is changing. So minus of n delta phi by delta t. So EMF will be N into delta phi b upon delta t, where the area isn't changing, magnetic field is changing, so area will get out N A into delta b upon delta t, and then given the value of time in 2 seconds it is changing from 5000 to 2000, delta b given, A given, delta t given, EMF is also given. You need to calculate the value of N. A simple problem based question based on a simple formula. Option number A is the correct answer over here, as you can see. Moving ahead for the next one, the fundamental frequency of a closed organ pipe is equal to first overtone. So the question asked from waves. First overtone frequency of an open organ pipe. Open organ pipe. If length of the open organ pipe is 60 centimeter, the length of the closed pipe is. So simple problem based on standing wave formation in organ pipes. You need to find out the fundamental frequency of closed organ pipe, that is V by 2L. Sorry, V by 4L. And for an open organ pipe, they are asking about the first overtone frequency. First overtone means the second harmonic, that is going to be 2V by 4L. Okay, 2V by 2L, that means V by L. And if the length of the open pipe is 60, then the length of closed pipe will be. So they are equaling them, you will get the value of the length of the pipe as well. It's a simple process. 1 V by 4 LC will be equal to 2 into V by 2 L naught. LO is for the open one, and this is for the closed one. You'll get the value of LC, that is 15 centimeter. Now, two conductors have the same resistance at 0 degree, but their temperature coefficient of resistances are alpha 1 and alpha 2. The respective temperature coefficient for their series and parallel combination is. So in series, how the resistors add up? So in series, the resistors add up as R1 plus R2. Based on that, you will get the value of alpha series as alpha 1 plus alpha 2 by 2. For parallel, how they add up? So for parallel, they add up in this manner, and once you will differentiate, basically you will find out the error analysis. What you will finally get is the resultant over here. Okay, so alpha p upon rp square into dt, and based on that, again what you will find out is in parallel also, the correct answer is turning out to be alpha 1 plus alpha 2 by 2. So the correct answer over here is option number B, that is alpha 1 plus alpha 2 by 2 in alpha 1 plus alpha 2 by 2. This is the temperature coefficient for series and parallel combinations. Okay. Moving ahead for the next one, identify the logic operation performed by the given circuit. So this over here is a NOT gate. Okay, this over here is a NOT gate, and this over here is basically the AND gate, NAND gate. Okay, and finally, when you will create a truth table, the final answer will be an OR gate. Okay, so A, you can keep the output as AB and over here as Y, take the NOT, and then finally you will get the correct answer as option number D, that is OR gate over here. Simple problem of semiconductors. In a plane EM wave, so EM wave questions have been repeated in 30th January shift 1 also, and again EM wave questions have been asked in this shift also, and in most of the cases we have seen electromagnetic waves questions have been asked in the exam. So the electric field oscillating sinusoidally at frequency 5 × 10⁻⁻10 Hertz and an amplitude of 50 volt per meter. The total energy, average energy density of electromagnetic field of wave is, how much is going to be the total energy density? It's a very simple problem based on a formula as half of epsilon naught E square, and basically E naught square, that is the amplitude of the electric field. Simple formula, this is taught in electrostats also, and over here also this is the energy density. Okay, so based on that, option number A is the correct answer whenever you will get. Moving ahead, if the wavelength of the first member, of Lyman series of hydrogen is lambda, the wavelength of the second member will be, if the wavelength of the first member of Lyman series. So first member of the Lyman series is basically from n is equal to 2 to n is equal to 1. The wavelength of the second member will be, okay, they are asking the wavelength of the second member. If wavelength of first one they have represented as lambda. Okay, so if the first one has been represented as lambda, then the second member will be from 3 to 1. This is the case, from n equals to 2 to n equals to 1, and the second member will be to n equal to 3 to n equal to 1. Okay, so what is going to be the value in terms of lambda? Comparing, you will get the value as 27 upon 32 lambda, that is option number B is the correct answer over here. Talking about the next problem, 4 identical particles of mass m are kept at the 4 corners of a square. If the gravitational force exerted on one of the masses by the other masses is 2 root 2 plus 1 upon 32 gm square upon L square, the length of the sides of the square is. What is going to be the length of the sides of the square? So there are 4 identical particles, they are kept at the 4 corners of the square, and the gravitational force exerted on one of the masses by the other masses is itna. The length of the four sides, it's a very simple thing, and basically by all the four sides, the masses m are kept as same. So one gravitational force will be over here, another over here, another over here. When you will find out the net vector sum, you will finally get the value as this. We needed to calculate the length of the sides. Okay. So this probably, I suppose, was equal to L only. This was equal to some variable, right? And it came out to be, yes, L square. And the sides were given as square A. One of the sides, yes. So we need to consider any x length or A length over here. And this L, whatever has been expressed, we need to express in that sense, right? So the value of A will be equal to 4 times L. The value of A will be equal to 4 times L, and that was in the options also, 2L, 4L, 3L. So final answer which you will get, considering the square, because there is no one mentioned that L is the side length of the square. So the value is given in this sense, GM square, everything will get cancelled, L square will be equal to 4 times A. So final answer is option number B, that is 4L, okay. Moving ahead for the next one. In the given arrangement of a doubly inclined plane, two blocks of masses capital M and small m are placed. The blocks are connected by a light spring passing over an idle pulley as shown. The coefficient of friction between the surface of the plane and the blocks is 0.25. The value of m for which capital M is equal to 10 kg will move down with an acceleration of 2 meter per second square is. So the value of small m, one of them is capital M, one of them is capital M, and another one is small m, okay. Now, the value of small m for which capital M equals to 10 kg will move down with an acceleration of 2 meter per second square. Okay, this will move down with 2 meter per second square. So this is capital M moving down with 2 meter per second square. So we need to find out the value of small m. It's a simple problem based on NLM only, Newton's laws. This is going to be mg sine 37. This is going to be capital mg sine of 53, and capital M value is given. It is given as frictionless, right? Idle pulley, the coefficient of friction between the surface is also given. So there's going to be a coefficient of friction also, Fk, that is nu mg cos 53, and over here it's going to act over here, because since it is moving 2 meter per second square, this will also move with 2 meter per second square, and friction force will act over here, and there's going to be a T and a T over here. So both of them will experience the kinetic friction force. Based on this, you can very easily get the answer, that is going to be option number B. Here are the equations written over here, okay. So option number B, that is small m value will be equal to 4.5 kg for the entire system to move down and move up with 2 meter per second square acceleration. The given graph represents two isobaric processes. Obviously, volume is directly proportional to temperature for the same mass of an ideal gas. Then what is the correct answer over here? So, sir, as we know, PV is equal to nRT over here. So, V will be equal to nR upon P into T. Now, if this is your Y, this is your X, then probably this should be your M over here, right? So, more is the value of slope, less is the value of pressure. Which one is having more slope? Obviously, P2 is having more slope as compared to P1, which is having lesser slope. So, since P2 is having more slope, that means P2 value will be lesser as compared to P1. More slope, less P. More slope, so lesser pressure. So, that is what they are asking. P2 should be lesser than P1. P2 should be lesser. Option number A is the correct answer over here. I hope this is simple. Okay. You just need to compare this with Y is equal to mx. If the pressure, yeah, and this is also an approach, right? For at same temperature, at any temperature, if you check over here, what you will see over here, let's check for any temperature. That means the pressure over here. Let's check for this pressure. Let's check for this pressure. Let's say the pressure over here. So this is volume V1 and this is volume V2. So for the same pressure, V2 is more, so P2 will be less, and V1 is less, so P2 will be more. This is also an approach which you can use. Talking about the next case, if the percentage error in measuring the length and diameter of a wire are 0.1 each, the percentage error in measuring its resistance is. It's a simple one, R is equal to rho L upon A. Area will be written as pi d square by 4. You can very easily get the answer. That is delta R by R will be equal to delta L by L plus 2 times delta d by d. So 3% is going to be the correct answer. That means 0.3%. Okay, option number C is the correct answer. Simple problem. Two charges Q and 3Q are separated by a distance r in air. At a distance x from charge Q, the resultant electric field is 0. The value of x is a simple problem that based on Q and 3Q, the electric field where it can be 0 is between them only. It is between them only. So that's going to be near to it and that's going to be far away from this. And they are saying at a distance x from charge Q. X from charge Q. So this is x. So this distance will be r minus x. And you can very easily find out the value of x in terms of r. Very simple problem, electric field because of this and this will balance each other. Option number A you will get as the correct answer. Simple problem. Okay. A force is represented by F is equal to ax square plus bt under root or bt to the power 1 by 2. Where x is distance and t is time. The dimension of b square by a square. This is a units and dimension problem, a very simple one. The dimension of A will be equal to dimension of force divided by dimension of x square. The dimension of B will be equal to the dimension of force divided by the dimension of t square. And A and B they are asking. The dimension of B square by upon A they are asking. The dimension of B square upon A. You can very easily find out the answer. The correct answer will be option number B. Try to find it. It's a very simple one. You will get the value of B as this, A as this, and B square upon A square is fx square by t. That is going to be this result. Okay. Talking about the next one. A rigid wire consists of a semicircular portion of radius r and two straight sections. The wire is partially immersed in a perpendicular magnetic field B equals to B naught J cap as shown in the figure. Okay. Now, the magnetic field force of the wire, if it has a current I in it. So there's a current I which is flowing in it. We need to find out what is going to be the force which will act on this particular wire, So there is going to be force on this portion of the wire. There's going to be force on this portion of the wire that eventually will cancel each other because the direction of current are different. Only the force which is in this section will count. Only the force which is in this section will count. Okay. So I L cross B. I L cross B. And L vector also you need to take this vector over here. So finally you will have the answer. B is your B naught only. I current is I and L vector over here is going to be 2R, right? So obviously 2 has to be the answer and the magnitude you can very easily check. I vector, I DL vector over here and cross B, it's going to be in the downward side, that is along minus Y direction. Option number A is the correct answer over here. And this magnetic field is not along J cap, rather it is along K cap. This is along K cap, right? Along positive Z direction, okay? So this is the correct answer over here. Simple problem, I L cross B. Then a small steel ball is dropped into a long cylinder containing glycerine. Which one of the following is the correct representation of the velocity time graph for the transit of the ball? So the graph between velocity and time, which one of the following is actually the correct graph? So obviously you know that the value of velocity, it increases and then it tries to attain a terminal velocity after some time because of the presence of viscous forces. So option number D over here correctly matches that scenario, wherein the velocity tries to be equal to that, right? It started from this point, and then it tries to match that. So this is the scenario which is happening. It will try to match the terminal velocity. Option number D is the correct answer. Talking about the second one, an artillery piece of mass m1 fires a shell of mass m2 horizontally. Okay. Instantaneously after the firing, the ratio of kinetic energy of the artillery and that of the shell is. So this is a problem based on conservation of linear momentum, right? Conservation of linear momentum, you can consider it to be a topic of system of particle and rotational motion. So basically what you can just say is an artillery piece m1 fires a shell of m2 horizontally instantaneously after the ratio of the kinetic energy. So the momentum are going to be same, right? The momentum are going to be same and the kinetic energy is p square by 2m. So momentum is same, kinetic energy will be inversely related to the masses. So k1 is to k2 will be equal to the artillery piece of mass m1 and shell of mass m2. So The kinetic energy in the first case, when the artillery has not fired, the ratio of kinetic energy of the artillery and that of the shell is. So kinetic energy afterwards the kinetic energy will be simply the momentum is same, so m1 is to m2 beta. K1 is to K2 will be equal to simply m2 is to m1. Okay, so the correct answer over here is option number D, because as you can see, momentum of both of them are same. So it's only depending upon the mass, right? So K1 and K2. Next, talking about the next scenario, the depth below the surface of sea to which a rubber ball be taken so as to decrease its volume by 0.02%. So basically, this question is of mechanical properties of solids, and the formula over here will be B is equal to minus of P delta V upon V. So delta V upon V they have given. You need to find out the pressure based on the bulk modulus, which is given as 9 into 10 raised to the power 8. Once you have calculated the pressure, then atmospheric pressure plus rho GH will give you the value of height. That is the depth they are asking about over here. Answer will be 18. 18 is the correct answer over here. Okay. Based on this, you can very easily find out the answer. An electron moves through a uniform magnetic field B is equal to B naught I cap plus 2 B naught J cap Tesla. At a particular instant of time, the velocity of electron is 3 I cap plus 5 J cap meter per second. If the magnetic force acting on the electron is 5 E K cap Newton, where E is the charge of the electron, then the value of B naught is, what is going to be the value of B naught? Now, this is the magnetic field, this is the velocity, and the force is simply equal to Q into V cross B. So this is an electron. So V cross B, you just need to do the cross product of them, and the final answer you already know will be in K cap. So through this, you need to find out B naught value. What is going to be the B naught value if 5 K is given as 5 E K cap? So E is obviously for the charge, that will cancel. So force is turning out to be 5 Newton. So how much is the value of B naught? You can very easily find out, and the answer will turn out to be 5. The formula which we'll be using is Q into V cross B over here. A perfect solution is given over here only. Okay. Equivalent resistance of the following network is. So as you can see, there is one resistor, one resistor, one resistor, one resistor. The point is, since they all are connected through a resistorless wire, so all of them will have the potential B only. They will have the potential B only, right? And over here also this will be A, over here also this will be A. So this is between A and B. So, and this resistor is short circuited, so no use of this, right? No use of this, and this is going to be C. So no current through this one. These two are in parallel, and then CB, CA, and then again CB. So this and this again are in parallel, and C to A is the circuit. So try to effectively draw a circuit between A and B over here with a point C over here. A and B have 3 and 3. A and B have 3 and 3. So over here and over here, this is 3 and 3. Done these two. Then B and C have 2. B and C over here, B and C over here. So these two, 2 and 2. So B and C have another 2, right? 2 and 2. And remaining this A and C has a 2. And no current through this because it is short circuited. So this is also done. So 1, 2, 3, 4, 5, this is the final combination. And now I suppose after restructuring this diagram, you can very easily find out the answer. The answer is going to be 1 ohm. The answer is going to be 1 ohm as is represented over here, right? For this 2 and this 2, it's going to be obviously 1, and 2 plus 1 is 3. Yes, so 3, 3, 3, it's obviously going to be 1. Now, a body starts falling freely from height h, hits an inclined plane in its path at height h, okay? As a result of this perfectly elastic impact, the direction of velocity of the body becomes horizontal. The value of capital H is to small h, for which the body will take the maximum time to reach the ground. This is a very good question. This is actually a very good question, and the solution is over here. This is the scenario which is happening. A body is falling from height h. This is from height h, and it is falling over here, and this is height small h. And after the impact, the body becomes horizontal, and now it will fall over here. The ball will fall over here. Okay, the ball will fall over here. So we need to find out. We need to find out what? Sir, we need to find out the value of capital H is to small h. Capital H to small h, for which the body will take maximum time to reach the ground. So we need to first find out the value of time, right? Once you have calculated the value of time, which is going to be an expression over here, then you need to differentiate it. And upon differentiation, whatever is the value of h you will get, that is the answer. So this was a good question, a combination of many concepts over here. First, motion under gravity, then collision concept, and then obviously a bit of calculus as well. Okay, so this was a very good question. A parallel plate capacitor with plate separation 5 mm is charged up to by a battery. It is found that on introducing a dielectric sheet of thickness 2 mm, while keeping the battery connected, the capacitor draws 25% more charge from the battery than before. The dielectric constant of the sheet is. So they are saying there is a capacitor plate with separation as 5 mm. This is charged by a battery. It is found that when we introduce a dielectric slab and the battery connections are there only, so the charges are obviously going to enhance, right? The capacitor draws 25% more charge. So obviously Q will be equal to, Q dash will be equal to K times Q, right? From the battery than before. The dielectric constant of the sheet is. So obviously I think you can very easily find out the answer that based on the value 25% more charge, that means this Q dash is 25%, 125 times the initial charge, right? 125 times the initial charge. And one more thing is there, it is not simply going to be K. Reason is because K is the scenario when the entire capacitor plate is filled with the dielectric. But over here what is happening? Only 2 mm is being filled by the capacitor plate. Okay, rest 3 mm is left vacant. Okay, only 2 mm is being filled. 2 mm is being filled and the rest is remained vacant only. So obviously the Q dash is going to be 100, first thing is clear, 125 by 100 times of Q. But you need to check what is going to be the effective capacitance over here, and then only you will get the answer as option number 2. A solution is given over here. First you need to calculate the C dash, and once you have got the C dash value, so Q dash will be equal to C dash into V. You can very easily find out the value. The K is turning out to be 2. Then two waves of intensity ratio 1:9 cross each other at a point. The resultant intensity at that point when A waves are incoherent I1 and waves are coherent I2 and differ by phase 60 degree. If I1:I2 is given as this. Simple problem. Over here I1 will be equal to 10C and then I2 is obviously given as C plus 9C plus 6C cos 60. You will get the value of 13C. I1:I2 the ratio has been given and that is equal to 10 by 13. So X value will be equal to 13 over here. I hope you have understood this. These are the values. They have given waves are coherent and I2 differ in phase by 60 degree, right? First of all, the ratio is given and they differ by 60 degree. So the maximum will be A plus B plus 2AB cos of theta. Okay, done, sir. The mass defect in a particular reaction is 0.4 gram. The amount of energy liberated is n into 10 raised to the power 17 kilowatt hour, where n is. So if mass defect is this, amount of energy liberated is simple. E is equal to delta mc square. This is a very simple problem, right? Based on that Einstein equation. So you can very easily find out n value is equal to 1 over here. Talking about the next problem, that is a solid circular disc of mass 50 kg. It is rolling along a horizontal floor so that the center of mass has a speed 0.4 meter per second. The absolute value of work done on the disc to stop is. So if you want to stop it, then obviously when the object center of mass is having 0.4 meter per second, it is also going to have an angular velocity. So it has two heads of energy, one translational kinetic energy, another rotational, and total work is to be make both of those energies equal to 0. That is going to be, so the work done to make it stop, completely come to rest, is going to be the net sum of the translational plus rotational kinetic energy, which has been expressed over here. Okay, so this is going to be the net work done. Rotational plus kinetic, that is going to be 6 joule. So correct answer is 6 joule over here. Okay, moving ahead for the next one. A small square loop of wire side 1 is placed inside a large square loop of wire of side L. The loops are coplanar and their centers coincide. The value of the mutual inductance of the system is. So basically you need to find out what is going to be the magnetic field because of the two coils, right? So one is over here and another one is over here. So because of the bigger one, whatever is the value of magnetic flux related with this, just related with phi is equal to m into the current over here. Phi related with this is equal to m into the current in the second one. And through that, you can very easily find out the answer of coefficient of mutual induction. That is what they are asking. The value of mutual inductance is. On solving, you will get the answer as 128 into 10 raised to the power minus 7. The value of x they are asking. Okay. So this is the correct answer over here. Now a particle performs SHM with amplitude A. Its speed is increased to 3 times at an instant when its displacement is 2a by 3. The new amplitude of motion is na by 3. The value of n is. So they are saying its speed is increased to 3 times. This is a very standard case, right? So you need to check on the equation of v square is equal to omega square a square minus x square for 2 cases. On increasing the speed, basically the amplitude increases and the omega remains same. So this problem, this equation over here will very easily satisfy the case over here, and ADH will turn out to be 7a by 3. They're asking what is the new amplitude, that is going to be na by 3. So n value will be equal to 7. N value will be equal to 7. Okay. So with this, we actually come to an end to all the questions of 31st January Shift 1 exam. I hope you have understood all of them. A personal suggestion to all of you is try all these questions without looking at the solutions. Try to find out the answers to all those students who are appearing for the next JEE 2024 session in April attempt, or basically who are preparing for 2025 or the upcoming years as well. The questions were good. The level was from easy to mediocre. There were few questions which were of a good quality, but overall the paper ranging was from easy to moderate. So I'll sign off with this note, and that's all from this side. Thank you and bye-bye to all of you.